Welcome back, everybody. Thank you for attending again. For you that are new and for you that are old, that have been here before, I appreciate you guys attending. Today, we're going to get right into talking about basic introductions to families. If you guys attended our MEP Force session, I did a session on families, same intro. It's kind of the same concept here. A lot of the same, a lot of similarities to that class, but in that class, I did a hanger or a strut. And in this class, we're going to kind of do a little bit more. We're going to try to get in a piece of mechanical equipment. So I'm going to do a VAV box. So on the agenda today, we're going to talk best practices, of course. As I go through this, I will be kind of mentioning, things, tips and tricks along the way. So if you guys are taking notes, please do so. We'll also talk about the importance of documentation and planning. I can't really stress enough on standardization, where documentation is going to play a huge role in that process and the planning. You don't want just everybody creating content. That's a big no-no, right? Content should be very strictly managed. And on top of that, of course, throughout this process, we're going to talk about some of the do's and don'ts for creating content in this presentation. So you will get in the recording all of these here. So I'll make sure I'll try to go through all the slides. Some considerations when getting started, right? Making the plan and sticking to it. This is important for everybody to know that creates content. Make sure that everybody, on staff that's going to be creating families in Revit understand what the plan is, and they're very versed in it. There's some considerations here. Again, mainly thing to take away from this is not to just wing it. You don't just create families off the cuff because there's a lot of information and detail that not necessarily complexity to the family, but information, data, that kind of stuff and performance really is the big one on when you're generating families. There is possible, where you can build a family that's too complicated and it just oversizes or bloats your project. So you want to stay away from that stuff. Now, when we're building families, templates rule the world, of course. We're going to start with talking about that, but there's also the main building blocks of the family that you have to really consider. Again, with the documentation, kind of having a set standard, building the frame and creating the geometry, really, from whatever information you're given. Think of maybe getting like a spec sheet or some information, a PDF, some type of, specifications on the item that you're trying to create. That will give you a good understanding of what types of parameters and building blocks you're going to need for this type of family. We're going to get into the editor, of course, right? This is really it's very similar to the project environment, but it's different, of course. You got some limitations here, and learning those limitations, you kind of learn them the hard way. I'll show you some cool stuff in here a little bit later. But these are really what we're going to try to focus on in the Revit: forms, connectors, datums, and work planes. They really kind of are what make a family kind of live, and the connectors are what make it MEP. Now, there's just basically 5 steps to creating a family. You pick the proper template, of course, just like on anything else. You build the frame for control. You test it out with dimensions and constraints to verify its actions. Make sure it works in the family itself. There's a couple of processes there that you can use. And then, of course, you generate the geometry itself. Make sure it works along with the framework, and then create your types. Of course, making sure that throughout all of this, you need to properly populate all of the proper data fields. So, think about also, the LOD 400, right? You need, a lot of information in these families that you might need to put or add additional to what comes with the family right out of the box, okay? All right, we're gonna get into best practices here when we get a second. Let's get back into Revit real quick. So when starting a family in Revit, of course, on the recent screen here, I can open up existing content or create new. Now, I'm going to do this in 2022 because it's the latest and greatest version. Everybody wants to see 2022. But here's the first note that I want you guys to kind of take down and consider. when you're creating custom content, custom anything, even practicing so that you can show or see or even test out with your peers, say if this family is something you guys want, if you learn from this, right? Always make sure that you do it in the oldest version possible. Right now, I'm doing this in 2022. We create some really cool custom families, and then next week we get a project, and I want to use those custom families that I spent time on, and that project's in 2020 or 2020, 2021. You cannot save any content backwards. So when you load content in a project and you see an upgrade, that's not necessarily an issue unless it's going more than 3 versions back. Okay, so here's another thing for you guys that are project managers, model managers. Your content, when you create these, you're going to want to create libraries with versions of years, so you can have at least 2 or 3 years of the same content managed, updated, purged, audited, opened, and saved. That'll keep your families from getting corrupted. Okay, there's some bulk updating options in here as well. We'll talk about. So with that said, starting a new family from scratch here, right out of the box, you should see your out of the box Imperial template. I'll use my drop down list here. So under program data, Autodesk, RVT, family templates, I'm using the English Imperial, again, library here, and you'll see a slew of Revit family templates. Notice the extension here, RFA, Revit family template files. RFT, I'm sorry, RFA. When we save these, they'll become the RFA, right? So it's RFT to start. Now, there's a whole bunch of in here that really kind of, you probably really wouldn't consider, with the exception of maybe like mechanical equipment, just to start straight directly with a piece of mechanical equipment. I'll show you the difference here in a bit. And then here, of course, the ones that I want you to take note of are these here called the generic models. So we have a slew of them here of different types. Ceiling-based models, meaning if this item, like say a fire alarm or a grill that's going up on the ceiling, if it needs to be ceiling-based, you would use this type of family. But here, consider this: with MEP and fabrication, we don't have real ceilings in our models, so we can't utilize this. That's more for architectural, where there's actual ceilings in the model. They're linked in or XREF'd into our project. So better yet, we would use a generic face-based family so that we could adhere it to the ceilings, the walls, any surface really is what a face-based family is. So if it's not being placed in the proper position when you create your family, you might have used the wrong template, right? So it's getting this right is really important. So what type of family are we going to create? A hosted family or a non-hosted family? A hosted family would be a face-based family is what I would recommend to start with. These others here, of course, they come along. There's options for this, or reasons why you would use these. And then the generic or non-hosted family is what we just call just generic model. Okay, so think about a VAV box. A VAV box does not get adhered to the ceiling or the structure or the slab. It's suspended in between, right? So it's hung from the slab above with supports, etc. Right? So we would consider a mechanical piece of equipment like that, a VAV box, a non-hosted family. So in our case, I'm going to use the generic model to start with. Now, the cool thing about this here is when you start with the generic model template, the big thing to take note of is that here under the properties palette is a space. Basically, it's a generic model, right? If I go into this properties pane right here, there's a properties window where we have the properties button, of course. We have our family types. We'll get to that in a bit. And then, of course, I have my family categories and parameters. This categories and parameters is where once we make up our mind and say, okay, this is a mechanical item, this is a plumbing item, or this is just, generic maybe, then you can switch up the categories after you've started with the generic model template. So when I need to make this mechanical, I can switch it here and click on OK, and it's now a mechanical piece of equipment, whatever I create, right? Now, the other option here is the family type. So you'll notice this here. With the mechanical category, I have a basic constraint for default elevation and identity data. This is what I'm talking about when it comes to the BIM data or the building information modeling part of this. Fill this information out. Not all of it needs to be like the image or what have you, but the model number, the manufacturer, the URL, maybe the assembly code, right? So this kind of information should be also considered when you're creating the actual content, not just getting, to draw boxes and cylinders and dimensions and stuff. You need to also fill this information out. So let me also show you this here. Under properties here, when it's mechanical equipment, we have a connector dimension option here for round connectors. Do I want to use radius or diameter, right? I can change the classification of this item here as a pump. I can set the part type if it breaks into something. My Omni class, of course, and then I have some other options here for positioning. Now, when I go back to generic, go back here to generic models, it just changes up just slightly. It doesn't really change. It adds the structural rebar when I'm under generic, so which is not something that I need for mechanical, right? So getting the category right is important. Once I've gotten my category correct here, let me turn my properties back on, my browser. What you're seeing on my screen here on this reference level is the floor plan view of this, right? The bird's eye view looking down. And one thing to take note of is this intersection right here is the actual insertion point of the family, okay? So as we build this, you'll see why, and this should not be moved. You'll see these are already pinned down, but this basically defines your center left, right, and your center front back. Now, what are these things? Well, in an actual 3D view here, in our 3D view, under the Create tab up at the top, we're going to get into forms and connectors in a bit. But where we usually start off is our helpers, our datums, and our work planes. Okay, I'm going to show the actual work plane that's active. And when you start off with the template or a family, you'll see that it's actually basically the reference level, right? So the floor, digitally or whatever is the actual work plane. So when I build something, it's going to be built off of this surface. If I go to this set button here, I can change the work plane with those two that come right out of the box. So I can make this a center left right work plane. So now it's kind of in the vertical instead of horizontally, right? And when I build, I can build off of this work plane, right? So this is what makes Revit easier to kind of model in, because you just basically can select surfaces or set reference planes or work planes so that you can actually generate the geometry that's needed, right? So now that you know that, let's go back here to this base plan. Let me go back and turn off my work plane here. Now, to get started here, again, this intersection is my insertion point. To get started is where I want to do is kind of talk about the plan, right? So what's the plan? Let me pull over this Excel file. So this is kind of something I just generated. It's pretty quickly, just kind of made all the fancy table stuff. But it basically just covers what information I need to fill out in this family itself ahead of time. So this is where we're going to standardize, and I'm going to understand or visualize here what everything is called, what I'm looking for, and what I'm going to apply to my family. So the plan is I'm going to, with the default elevation here, I'm going to need to create some electrical box parameters, the actual VAV parameters themselves, connector parameters, and then fill out some of my BIM data, right? So we'll get to that here in a second. So this is the plan right here, okay? Now, what the actual family is going to look like, that again, you just pick a spec or choose, whichever one the manufacturer, does not provide or what have you. And, before we getting started here, consider that too. You have to see if it's already created for you or built. You can take those and reverse engineer them, clean them up. Some of them are pretty strict on the way they're built, so be careful. But we'll talk about external content from other sources at the end of this in a bit. Okay. So where I get started here, once I've gotten kind of checked all my settings and configurations here so far, I can then use what we call the reference plane command to kind of start building the bone or the structure here, right? The bone work or the framework, right? Reference planes, again, are finite planes. So what I'm going to do is I'm just going to generate two reference planes here vertically and then label them. I'm going to hit escape a couple times to get out of the command so that I can get to the label here. Now I can label them in under identity data, or I can label them in the view. And again, I'm just going to capitalize everything just to make this all stand out and abbreviate. Say right and left. Okay, so this is going to be my my left side, my right side. This, of course, is my center left, right, and this is my center front, back. So I need to create a couple of more reference planes. So I'll go back over here to the Create tab and create a couple of more. I'm going to create a couple across left to right, here to here. Now, with these created, right, I'm going to go ahead and label these. I'll call this front, and I'll call this back. And again, it's important to label them so that, again, when I'm over here in this view, in my 3D view, or I'm trying to build off of something, and I go to set the work plane again, right? I can go to these new work planes that we just created, or reference planes. So if I want to go to the left, it's now left. Okay, so let me set this back to set reference plane. Set this base first. So you got to make sure you know what you're drawing first. Okay, so I'll go back here. So now that I've created my structure here, I need to then now generate my dimensions and labels or parameters. Okay, so if I go here to my families and types, you can do this a couple of different ways. You can generate the actual dimensions and make sure that everything is working first, and then come back and fill out the family types. Down at the bottom is where all your options are. You can modify existing ones. You can generate new ones with the little sunburst there. I can delete, duplicate, rearrange the order here, and then of course change it from ascending to descending if necessary. We'll get into those here in a second. Before we create the parameters, I could also test out the framework. So either here under the Modify tab, you have the Measure command. Under Annotate, I've got the Align Dimension here, or I like to use the Align Dimension in the Quick Access toolbar, right? This is just the simple Dimension command. I need to create some dimensions here in order for this structure to work. So this is key to creating the first dimension. Let me show you this. To create it, what we call an equality constraint, I need to select the reference planes in sequence, in order, without stopping. And then I move away or on the actual dimension to place it. And then you'll see that little EQ symbol pop up so that I can make those equal distance, right? Now let me undo this. Where users get it wrong and where I got it wrong in the beginning was I would do it this way. Place 1, place 2, and then, Gabe, I can't get the EQ to show up, right? Where's the EQ? Well, it needs to be in consecutive order, and there's no way to fix those. So deleting them and then redoing the command again over consecutively like this, and then placing them, well, you get this, what we call an equality constraint. What the equality constraint is going to do is when I create this overall dimension and I flex this framework, notice how it's growing equally, right? So it's changing equally here. That's kind of the point of that. So now what I need to do is set it up for the side here. So do the same thing. I can pick the align dimension here, pick consecutive order, click, make them equal, create my overall dimension here, and place. And then I'm just going to hit escape again once I'm done and drag my reference planes and see if I can get that to work. So it's working and it's moving as I need, okay? Next thing that I would do here is then, again, I can create the parameters and start labeling all this or whatever, or start to now create what we call our forms. So my forms, I'm only going to show you an extrusion here, and it's all really it takes is an extrusion with different shapes. But the forms, when you start a form here, it starts you into what I call sketch mode, or what we call sketch mode. You've got to look at the ribbon and pay attention to the ribbon. I'm in a green contextual tab called Create Extrusion, right? My draw panel is for us AutoCADers. This is where you would draw lines and rectangles and polygons and circles and arcs and ellipses, etc. Right? So I would use the rectangle command here and use my intersection to intersection. It will pop up these what we call alignment locks. right, for the sketch. So if I lock this sketch to the actual reference planes that I'm drawing to, watch what happens. When I finish this out, this is the key to this sketch mode thing. If you see the green check or the red X, you need to do one or the other to get out, right? So when I'm done with this, I need to finish this out. Now, before I finish this out, let me show you another common mistake is if you get really crazy with the drawing here and say you left just maybe a piece of sketch hanging out there and I try to hit the green check to finish it, it'll tell you and even show you sometimes it's overlapping lines in the sketch. So think of this like a polyline where it needs to be a closed loop in order for you to kind of finish out the sketch. Now, it doesn't mean that you can't have complicated sketches. It's not just a simple square. We'll show you some other options in a bit as far as what I mean by not complicated. I'm going to go ahead and finish this out. Now, with that constrained, I'm going to turn on some shading here so that I can drag now and see my actual, the body or the chassis of the VAV box kind of come to life now, right? And I can see it stretching along with these reference planes as well as these dimensions. Now, that's what all these are, just dimensions now. To create an actual parameter or a label the dimension, you can highlight the dimension that you want to actually label. And in this pull down list here, if the dimension exists, is where you would assign it. Now, if there isn't any, and there isn't any in this case, of course, there's this button right here to the right where I can actually create the actual parameters that I'm going to need to use to make this work in a project. Okay. So what I can do is I can click on this and it's going to take me to the parameters option. Now, again, what are parameters? These family parameters, there's a couple of them. These that come in properties that I showed you earlier and in the categories list, those are family parameters that are kind of built in. But they cannot appear in a schedule or tag, okay? So here's something to keep in mind. Again, when we're still under this family 2 still template, when we save this, the name can really make a difference. We'll talk about that in a bit. The shared parameters is typically what you're going to want to use. This is best practice for creating custom content, especially if you guys are going to have, a team of people creating content. Everybody should be on that team, should have the same shared parameters file. And let me show you a quick example of what a shared parameter example could look like. Let me go in here. So I created this one just for this training, but you can have your own shared parameter for like BIM data. And instead of you trying to figure out what this information needs to be, the actual parameter data itself, and again, I call it installation or location. Joe calls it install or locale. Bob calls it, inst and loc or something. And there's 3 of the same parameter, but they're all 3 of us that are on the same team created differently, right? That's where shared parameters really comes in, and it will help with kind of managing your standards in-house, as well as for schedules and tags. So, you can, again, make sure that your schedules and tags are all populating with the correct information. It's a global setting when you update and tweak and change these parameters, right? So there's different types of parameters I'll get to in a bit, but I can go to connections here. So if I wanted to add connections for my supply air, my electrical box, and then some mechanical connections here for my VAV box, the unit height and width, etc. Right? Now, this is best practice with the shared parameters file. I'm going to just create them in this family here as family parameters, so you can kind of see what the difference is. Okay? So this one, I'm going to call this, just leave this all cap locks, unit length. Now, the difference here on the right for between a type and an instance parameter is this. When I put this VAV box into a project and I want to change the length of it this way, do I want to change it to 4 foot from 4 foot 6 to 4 foot, just this one, or do I want to change every one of those in the project? Okay, if I want to just change this one from 4.6 to 4 feet, that's where I would make this parameter an instance parameter, and I can have one that's 3 foot, 2 foot, 6 foot, 10 foot, 12 foot. It doesn't matter. That's what instance means. A type parameter means that if I change this unit, this 4 by 3 unit, to a 3 by 6 unit, it's going to change all of those to 3 by 6. And if I have 10 copies of them, they're all going to update. That's what we call a type parameter. Okay, and I'm going to make this an instance for now. Now they're common. It's going to be a linked parameter. And then, of course, where do we want to group this under? The grouping is, look at the properties palette over here on my side, my left-hand side. You see the dark gray here, graphics, text, and other? That's what the grouping is here. So you can actually group these parameters. And like for the unit, I'm going to group them, say, under mechanical here, just to kind of switch it up a little bit, right? And then the tooltip. This is where you can provide info to users, right? Or, kind of show people how to use it. This family. Information, maybe it's company information, or, possible, that A equals, this value. B is going to equal that value, some kind of like legend here, maybe. Let's see what it looks like when we get done. Let me click finish this here. Click on OK. Now, when I click away from this, right, and we use this family, look when I hover over the actual dimension. It has all that information in there as well, the description, when you hover over it. And look at the actual dimension. It changes. It's not just simple text anymore. It actually has, it's a label. It's a parameter value now, okay? So doing the same thing over here, I'll pick on this 3/8. I'm going to click on the parameter here to generate a new one. This one, again, to be consistent, we'll call this unit width. Instance parameter, and I'm going to put this under mechanical. I'm not going to worry about the tooltip. And now I have these parameters created. If I go to my families and type now, you'll see that now under my family and types list here, under mechanical, I have those two new parameters. And with the parentheses default here, that means those are instance. Okay. If they're typed, the default word goes away. So if you see that in here in a bit, you'll know why. So I'm going to say this should be 4 foot and this should be 2 foot 10 as my default standard chassis there. All right. So there we go. So now that I've generated my VAV box, or at least the basis of it, right? I can test this out. All right, let's go take a look in 3D. So if I go in here and I go into this 3D view, you'll see that this plane doesn't look right, but it's just, again, you just needs to be kind of moved in position, but you see how we're building it off of the surface. Now, if I need to start building off of this, different other, or putting other geometry on here, this is where on the Create tab here, this is where the work plane tool comes in, or the work plane panel. I'll set the actual work plane myself. Now, instead of picking one, right, I can do this visually as well by using this option to pick a plane. So I'm going to say pick a plane here, and I'm going to pick the side of the unit. And notice how with this turned on, again, I can turn this on and off if it kind of gets in the way. I can turn it on and off. It's the show button here. But now that shows me which side I'm actually going to be drawing off of. So when I go back to the extrusion command now under Create, I'm not going to be drawing a box on the floor going up anymore. I'm going to be drawing it off to the side of this unit. Again, I'm going to use my rectangle command. I'm just going to kind of eyeball this in. And I'll extend this a little bit. Finish this out. Now I've got my electrical box, right, or at least the beginning of one. This one does not have a reference plane yet, but I can add to that here in a bit, okay? So continuing on, let me kind of start finishing this part up again. Let me go back here to this side. So now I need to add a little bit more geometry to this. On this face over here, I need to add my inlet or outlet, right? So again, I'll go back to the Create tab, and I'll set the work plane. Hover over the edge of the shape here, and also if you have this like shaded, it's hard to see. Pick a plane. You can see it there on my screen, but turning it off and on and hovering over the edge really is going to help. Okay, so let me get this geometry kind of created real quick. This time I'm going to create an extrusion again. And this time I'm going to kind of cheat with the line work there. Let me show you what I mean. I'm going to pick on this here, and I'm going to just draw intersection to intersection. And let me draw this straight down just in case. And then I'm going to use the circle here to get that midpoint there and draw this out, say at 6 inches. And then I'm going to use, these are construction lines, so I just use that to kind of center that shape there. And then I can finish this out, and now I've got, the beginnings of my duct inlet or outlet, right? Now the depth here, or the extrusion end, that defaults to a feet. So this is probably going to be something like 5 inches or 3 inches or whatever, right? And then I'll kind of, you can extend these with these little grips here. I can draw this, in whatever, shape I want, right? So I've got some more to do here. So now I've got to put in my outlet back here on the back end. And again, the same process. I'll go to the Create tab. I'll set the work plane by picking the plane manually here, setting it. Use the Create tab and use my extrusion. This time, I'm going to draw a box. Actually, I'll show you the Pick Lines tool here. So with the Pick Lines tool, the one with the green line on it, the very end here, I can use the offset option here on my options bar. So I'm going to say I want to offset, say, 1.5 inches from the top. And I'll hover over the edge here of the top, and it's going to offset 1.5 inches off the top and the bottom. And then off of this side over here, I'll go ahead and just give it the 1.5 inches offset to the inside, and then I'll clean up my sketch, hitting escape when I'm done with the sketch, using my trim command right here to trim this out, making sure I clean it up, make sure it's a closed loop, right? And now I can use my dimensions here and say, well, let's see, it should be 1'4", and then I can, kind of scooch the sketch over a little bit. I'll get this centered here in a second. Go to an elevation view. Make sure I've got this centered. Again, I'm just using one approach here, but it's really up to you how you want to do this. There's no, one way of doing things. You kind of figure out your own approach. There's, again, cheating right there, right? Doing the 1'4" by, what do we got? 9 inches there. We'll say this will be 6 inches. No, that's right. Foot. I think my my height needs to be set. So let's do this real quick. Let me show you here. So with these here, with this, the reason why I'm drawing these is because when we add our connectors, you need to have like a little bit of what I call like a tap out, right? If I needed to have like piping or electrical connectors here, what I could do is, since this plane is active, I'll just show you a little quick sketch. What I would do then is draw in some circles here. Come on. And then set the depth of those circles to say like 1/8 of an inch deep. And now I've got some tap outs there that I can put in a pipe or electrical conduit connectors or whatever that I can actually put in a connector. Because you'll see when I place connectors in a bit where these might come into play. Okay, I'm just going to leave those there for now. Those actually should be on the box back there, but I'll remove those in a bit. So kind of, again, getting my geometry created or drawn is really important. The one that I missed is in the elevation here was we didn't have a top reference, right, or height. So I'll go back here to the Create tab and use my reference plane, and I'll just draw it. Don't have to get it perfect at first, because you create it, you label it. I'll call this unit top for my reference plane, just to make sure I got that right. And then I'll add the dimension here to the reference plane, or the level here. And then I can control the reference plane with my dimension now. And this should be, what, 1 foot? Let's say. So now with that at 1'4", I can generate a new dimension, or a new parameter. Spelled today. Here we go. Instance parameter, group it under my mechanical. And now to make my unit stick to this, right, I would use, you can drag it here and let go once it hits the reference plane. You'll see the lock there, because I didn't do this. I did the sketch in one plane, but in order for me to lock this in the elevation plane, I have to do it manually. Another thing to get used to when you're doing this here is using the align command. That also gives you that alignment lock. So I can do align where I want it to go to the reference plane, what I want to send there, the top of the unit, and then it gives me my alignment lock. So I can lock it there. So now when this thing grows, it automatically goes along with it, okay? All right, let's take a look and see what this looks like. Let's go into our 3D view here, go back up, right? So now I've got kind of a couple of options here that I can now, actually this I need to fix. Let's see, let me go to the front view, set this to a hidden line, and it's my right view. Set my detail level and my background here. I'm going to edit my sketch here. Make sure that I got this thing right at the center where I want it. Move it. Snap center to midpoint. Finish this out. Now, one thing really quick before we continue here is this. One thing to take note of as I'm sketching this. What if I needed this cylinder not to just be a solid cylinder? I mean, really, that's what we want. But if I wanted to give it a little bit more detail, one option, what I did in the beginning was to do something like this here, where I set the surface here, right, the work plane. So now I'm at the face of this cylinder here. Let me stretch this out. And then I thought, okay, well, I'll go to now under forms here, create a void form, right? A void extrusion, circle, and kind of give this a little bit of a thickness there, right? Finish it out. And I turn off my work plane here and set this to a grayscale, give it a little bit more view there. You can see how I gave this a lip, right? Something like this here. Actually, this needs to cut through. And it looks, that looks kind of good there, right? I can maybe put the connector towards the back end now, and you can kind of see through it, right? Well, the problem is like when you move things around, or when I move this object here, when most of the time that void is not going to kind of come along with it, right? Another thing too is that this is increasing file size, this void here, because it has to cut out that geometry. So you want to stay away from those as much as possible. One thing to remember is this. What I should have done was, instead of making two pieces of geometry there, void and solid, I should have just created this in the sketch, because I could have a closed loop, two circles within each other, and that created the same exact situation without a void. So there's no void that comes along with it, right? So sometimes you overthink it. Sometimes you don't think, you don't think it all the way through. Things like that come up. So just keep that in mind. Just try a couple of different ways, see if which one works best for you, but think about it in the sketch too. I was trying all types of revolves and blends and other things to make that work, but the easiest way to get it done was just to kind of simplify it, right? All right. So now that I've created this unit, let's go back under my parameters here, and we've got now all my unit lengths and widths and heights set, right? Let's go ahead and test it out in a project. So I'm going to close out of the extra views here, and I'm just going to open up a basic project here. Mechanical default. Now, here's one common mistake that gets done that happens as well is, actually here, let me save this. I forgot to do that. save as family. Let me put this in my training folder here. So VAV take 1. So before I save here, this is important as well to take in consideration. Sometimes when you're working with content, it's better to you really want to keep the name of the family down to a minimum, under 28 characters. Abbreviate or get rid of it. Get rid of as much as you can. I've seen content in projects lately where we're auditing these models and they're getting manufacturer specific stuff, especially in fabrication, on the fabrication side. And these families have some ridiculously long name that is just could cause corruption in the project. So the naming conventions can be huge because not only can you call it what it is, maybe give it like a model number. I'll kind of just, ASTI 0121 or something like this. You can type it in here, abbreviate it. But also, kind of with the size range or something. Maybe it's a size 28 through 32 or something. If you can't get that information in a schedule, if you put it in the name of the family, you can then filter by that as well. So the family name is a common item to schedule or tag, right? So this is something that maybe you can use if you're not getting the right information in a schedule and a tag, in other words, but you're trying to tag this or tag and schedule custom family. Maybe the name will help with that process, in other words. Okay, so maybe the value can go in the name. I'll just leave it something like this and save it. Now, the two options here under the Create tab are my load in a project. This is when you're testing it out, and a load and close. This is when you make changes to, say, content, update it with BIM data or what have you, and you're just saving it right back to the library that everybody's working out of, right? The load in a project is what I recommend you guys doing when you open up somebody else's stuff, right? Somebody else's family or creating your own. Always test it in a template. Never test it in a working project. You might break it, right? So always test it here first, and then test it yourself in a project, and then have maybe a couple of people on your team test it out as well. You'll get some good feedback, and it'll really help kind of making or standardizing, all the way through. Okay, I'm just going to load this in the project. And now when I load it in and I place it here, you'll actually see the actual family, right? It's dark and bold. Let me turn off my thin lines, right? Now, if I would have, this is one other common mistake. If I would have left this as generic models, loaded back into my project, every time I get this, I always use the second option, override its existing parameters, category and parameters. Notice how it kind of like fades out, right? It's grayed out because it's a generic model and I'm in a mechanical template, right? So this is another thing when we talk about checking the performance of the family, checking to see how it works, how it's going to work in your company template, right? That tells me, oh, I built all of this, but I forgot to make sure that it's in the right category, mechanical equipment, okay? Click on OK. When I load it back in and override, it should bold, darken up, right? Like that. See, it gets bold. All right. Now, here's another thing with these families that you got to understand with these reference planes. Let me turn these off real quick. Something that I try to stay away from. Notice in 3D when I pick it here, nothing really shows, but when I'm in a floor plan view, I get these arrows. Let me turn my thin lines back off. And I can stretch these things because of the instance parameters, right? This is bad for like family performance when you have users moving these things around or making adjustments, because these things can change size. Look at my dimensions now. This is the instance parameter, right? That means that I can make two of these, and I can change this one here to say 3 by 2. That one's going to fix, but this one will stay the same, okay? That's the difference between the two types of parameters, okay? Now, how do I fix that in the family? Let me show you something here. When I go back to my reference planes here, and I'm going to select on all these 4 reference planes, the ones that I created, not the original 2, right? I'm going to grab my 4, and over here under Other in the Properties palette, if you can set these to the proper sides, and use these as this naming conventions here. And then there's the top three that you really want to focus on. Not a reference, strong reference, or weak reference. If you're having problems with it aligning or being able to pick on a surface or something of the family, you can make this a strong reference, and then you can use the align tool or move tool better in a project. Now, weak reference is what we're seeing now with those double arrows, and I can accidentally modify the chassis or the body of the VAV box. If I set these to a not a reference, all four of mine to not a reference, and then load that back into the project, when I pick on this, no longer do I have those arrows to accidentally change the values here from what, a good standard size actually is. I still want this kind of control over the dimensions where they're instance like this, but I don't want to be able or have my users stretch this stuff out by accident, right? That's a big no-no. So it also has to do, again, with the reference planes that you built, the bones, right? So you have the reference option here, is a reference or not, okay? So those are the three big options. And of course, when you're doing that, that's the up here on the help up at the top right, you can do reference planes or type this in under your help, and it'll kind of tell you everything you need to know about reference planes and all of those options, okay? So it's all under the question mark when you're doing this. Okay, got a little bit of time left here. Now, the last couple things that I need to do here in order for this to work is to make this MEP, right? So this is, again, the reasons why I did these little tap outs or the extra geometry. This part right here called the connectors, this panel right here, we've got electrical connectors, duct connectors, and pipe connectors that we're going to worry about, right? And I'll put in a duct connector and I'll place it right here. And this is, again, why I place it on the edge of that surface. So it's going to be sticking out on the outside lip there, right? But it's still not in the right shape, but that's okay for now. On this side, same thing. I can go to create here, pick on a duct connector. I'm going to hover over the surface of the cylinder there and place in my duct connector, okay? Now, the electrical connector, we're just going to throw in just for giggles. Go here and do electrical connector. I'm going to say that this is a control, and I'm going to put this on the surface here. Now, the reason why I do this, because you might see this in other families, and it's just for the electrical side of things in Revit, but this connector, you can't control the scale or the way it looks. It is what it is, so you need to see what it looks like, okay? Now, over here, I can control a couple of things. When I pick on this connector here, I'm going to set this to a round shape so that it's round, right? And then I can set my diameter here. But before I do that, I need to kind of create a couple of more parameters. Same thing over here. I can set this to a rectangular, but I need to make this say 1'4" that way, right? And then what was it? 1'4" by, oops. 1'4" by, I think I did 9 inches. Or was 10. 10 inches. There we go. So again, I can kind of change the shapes. Now, the better way of doing this is adding your own parameters, right? So let's add in a couple of more. So I'm going to call this, say, supply air width. I'm going to make this an instance parameter. I'm going to go and leave this under dimensions for time's sake. I'm going to go and do supply air length instance. And then I'm going to do a supply air inlet instance. This time I'm going to use HVAC, and then I can use this one called duct size. So you'll see the difference between a length and a duct size when it is a duct size, or when we're actually doing this for duct. Outlet, discipline, HVAC, duct size. Click on OK. So now I've got my dimensions here for my inlet, length, outlet, width, and then I can do the order, right? So I want my length and width to be together, and my inlet, and outlet to be together. So I'll move these down, inlet, outlet, length and width, move those together, height, length, and width here. And let's go ahead and do this here. So I'll click on OK. Now, the reason why I created those is so that I could take this, now this connector here, and I can use the, on the connector itself, what these little buttons right here to associate the parameters. So for the height would be my, we'll say, should have been height and width. That's my fault. Oh, actually, height would be length. Sorry. And then width, I can associate it with the width. Now I need to give them values. That's my fault there. So height, length would be 10 inches. And inlet is 6 and 6. So let's try that. There it is. So now it's 10 by 4. Now you see how it's grayed out? That means that now I control that connector dimensions with these dimensions here for my connections, right? My 10 and 1'4" for my supply length and width. Now, if I went back in here and I can change the length to actual height, I can use the pencil, change the name. That I can do. If it was a shared parameter, you'd have to delete the parameter and recreate. So that's another thing to take note of. So now I've got that one associated with the right dimensions. I take this one here and I can associate this dimension here with my inlet. And then I can say that I want to be using radius or using diameter or radius either way. I can, let's see here. So it's a diameter, inlet is 6. So let's say, oops, not 1 inch. This is the difference between a duct size and a length. The length's going to give you feet and inches, but if you're only using inches for that dimension, you can use the HVAC duct size and it'll give you just inches like this. So if I did something like that there we go, right? So it actually should be using radius. So we'll come back to that in a bit. But again, now that I have all this done, right, I can load that in the project for testing, override my existing families here. And now when I select on the family, I've got these connectors. So I can start drawing my ductwork. And of course, this is Revit families, but I can also attach in my, my fabrication ITMs. Load in my database. Design the fabrication. Supply air around. Finish it. Design the fabrication. Rectangular. And now I have my family. Okay? And I can control it now with these dimensions. So you could also make these dimensions like, you know, I could have made the dimensions for the box. Let me show you this one here. Let me close this out. So I kind of made another one here with a little bit, you know, with the time that I have, it's pretty short. So I've kind of created one here, this one. Oh, not that one there. Sorry, wrong one. Which one did I create? This one here. And let me show you what it could look like. So something like this here. Same things. I didn't fix my references on that one. This was a variation of it somewhere. I didn't have my connectors on it. Let's see. Was that the right one? Oh, yeah. So also one last thing here. So like to visualize this, let me go to this one and show you this here. So what if I wanted to be able to turn something on and off in a project, right? I'm going to create a new one here, and I'm going to call this electrical box. I'm going to make this a type parameter, and I'm going to call this or make this what we call a yes/no parameter, okay? A yes/no parameter is a checkbox. So what that checkbox is going to do is when I pick on this box here, there is under graphics called a visibility setting. I can again associate this visibility setting with this electrical box yes no parameter. And when I use this in the actual project, if I want to turn the box off and on, I just check the checkbox to turn the electrical box off and on. So if you have certain portions of the model, this is where the detailing part comes into these families, right? Where if you put too much detail in here, it could be bad for the family. But maybe at a certain view, I just need to see the, the main part of the box itself. You're considering clearances in your void forms. Here's the problem with the clearances, right? Clearances are void forms. They're not necessarily going to improve the file size. They're going to kind of bloat up the model as well. So you would, if you needed a clearance, you would, more likely use in the reference plane here, maybe like a 2D symbology here. Use your model lines to draw in, say, I'm going to just fake this in real quick. Let's see, hidden lines. And then load that into the project. So now I've got like just line work that's getting kind of giving my user clearance. But the more model lines you do, again, it's the same no matter what. You just have to find that perfect medium. Too many model lines is going to break the project, or possibly introduce corruption eventually into the family, and then into the project. So just keep it at a minimum. You don't want to, draw in the vents, the brand of the company, none of that stuff. You want to kind of just stop, with just as much as you need for this project. And then, of course, finally, the main thing is the information, right? So put in your model number, put in your manufacturer, fill out the URL and the description, maybe give it the assembly code number, right? Some of them you don't have to fill out, but these you can, so that when I go to schedule and tag, I have this information to pull from. Okay. All right, kind of ran long there. Let's see, is there any questions before we call it a day?
Not yet, but if you're out there and you have a question, now would be the time to type that into the Q&A. Gabe, thank you so much for that presentation. That was awesome. If anybody has a question and maybe they can't think of how to put it into words right now, what would be the best way to reach you?
Let's see here. You can email me, of course. Let's put in my email address here. I'm usually in training. So if it's a support case, of course, always go through our support, ftg at support.com, at ASTI.com, I'm sorry. Support at ASTI.com. And of course, if you get it to me, I will forward it on as well if I need to. But definitely, you can always shoot out an email, and I'll be more than happy to help. For any reason for not using nested connection shapes. The only reason why nested families would not be used is, again, because it's hard to control them in the project with additional parameters. So there's no real reason why not to use them. But other than test them out as best as you create them. But I've seen companies like plumbing companies create like nest or do for lack of a better term, like an assembly where they built the lavatories, cold water, hot water connections, and P-trap all built into plumbing family, right? So with nested families, other families within a family. It's just that you've got limited control, okay? So test it out and see what you would have. Do you have access to the recording? Yes. Once this is done, the email, when you guys registered, you'll get an email for the video or for the recording. If you select the wrong template type, say hosted, you cannot change that. Yeah, you pretty much have to start over if you pick non-hosted versus hosted. But any of the categories, mechanical, plumbing, generic, that is interchangeable. But yeah, it's better to just rebuild it, not try to copy paste from one family to the other. You'll see there's a lot of limitations between transfer project standards into a family, copy pasting into a family, annotation and detailing in a family. So just take a look at those options. And, again, if you have questions, feel free to shoot me an email.